Hello and welcome back. Let's start by just kind of recapping some of the logic we've used up to this point. So I'm here in my server file, and if you recall, in the game's ready game method, for each and every specific player, so we've got each and every specific player, so these are running in individual threads for these players. We then start a thread to receive player info from them during the game as it's being played. Essentially, we're going to receive a player's updated coordinates as they move around the game window. So now let's go to the receive game player info. All right, so here's receive game player info. You can see here we're getting information from the player and then updating or setting that information to the player on our server side. A player has changed its state, so the server needs to somehow process that change and add it to all other changes, compile those changes into a game state, and then ship it back to each and every player. And so if you scroll down a bit, you can see that we are calling process game state. And we've already written process game state, but we've ended processing that game state by calling send game state, which we currently have to write. So let's start working on sending this game state back to our player. So we'll get rid of pass here. The first thing that we'll do is we'll initialize a blank list called game state. Game state is a blank list. Perfect. And this is going to hold all of our players' information. So now what we'll do is we'll loop through each connected player's player object. So we're going to turn their player object into a dictionary. So we'll say turn each connected player object into a dict, then a string, then encode. Well, we'll just say dict and then string because we're not going to encode yet. So what we'll do is we'll say for player object in self.player objects. Remember, we got that list in our game object of all of the connected player objects. Let's turn the player object into a string. So we'll say player JSON is equal to JSON.dumps. So what do we want to turn into a string? We want to turn the player object. But this is a Python class, and we can't really do that directly. But what we can do is call __dict __ on this class. So here's the class that, a particular player. We're going to get a dictionary version of it so that all of the class's attributes are key value pairs. Now we have a dictionary, and we've turned it into a string, which we can later then encode. So let's take this string and append it to our game state now. So we'll say game state.append player JSON. All right, so that looks pretty good. So now game state, if we've got 4 players, game state is going to have 4 elements in it. Each of those elements is going to be a string representation of a dictionary representation of our player object. So that's, there's a lot there. But now that we have it, let's send it back to this particular player. So we'll say send the whole game state back to this player. And so remember, we're running these in threads, so everybody's going to get this. Everybody, all of our players are going to be this player in their respective threads, if that makes sense. So we'll say, okay, this is a list, and we can't encode a list, so we got to turn this into a string representation of the list. So we'll say game state JSON is equal to JSON.dumps game state. All right, so now that list has become a string, which we can encode. Let's get the length of this list as our header. So we'll say the length of game state JSON. But we know that this is an integer, and we're going to want to add some white space to it. So we're going to turn this into a string. And now that it's a string, we can use the length function on it. So we can say, well, the length of our header is less than our header length, which is stored in our connection object. So self.connection.header length. What do we want to do? Well, we've seen it before. We're going to just add a white space character until the header is the exact size we declare it to be. Now that it's that exact size, we'll send the header over, which has information about how big the next incoming packet is going to be. So we'll access our player socket, which is right here. All right, so player socket.send. What are we sending? We're sending our header, but that needs to be encoded. So we'll say .encode, and our encoder is found in our connection object. So self.connection.encoder. All right, now that header is over, let's send the game state JSON. So we'll say player socket.send. Why can't we just send the game state? Well, we can't encode a list, so we turned it into a JSON so we can encode it. So we'll say game state JSON.encode, and we'll pass in self.connection. Oh, I got to spell connection right. I know I've made that mistake a few times. Self.connection.encoder. All right, wonderful. So this is pretty good. So now that's going to send our compiled game state, but we've also in the process game state, we've updated our time. So let's send our time over too. So now we'll say, hey, in here, let's also send the server time. So let's get a header. So we'll do header is equal to, so if we let's think about this, self.round time. I believe round time is an integer, so we're going to cast it to a string. All right, and now we want to get the length of this string, so we'll call the length function on this. And now the length is going to be an integer, and we want that to be a string. So I'm going to cast that to a string. I think we have to do that. Maybe we don't. I know this works. I think that is the thought process, right? If this is an integer, in order to call length, we got to cast it to a string. When we call length, we get an integer, but we want it to be a string. Okay, so now that it's a string, we'll say while length of our header is less than self.connection.header_length, we will add a white space character plus equals to the end of our header, and now we'll send through our player socket. So player socket.send, we'll set our header dot encoder self.connection.encoder, and then we'll send our current round time. So we'll do player_socket.send the string representation of self.roundtime, because I'm pretty sure round time's an integer, and we want to encode this. We got to make it a string. So it's a string now, so we can encode the string with our self.connection.encoder. Okay, so we'll send that time over. That way, each client knows how much time is left on the round, and we've already updated that time in our process game state right here. Okay, so I think this looks pretty good. I'm going to save my server, so Control S to save the server. And so now what we have to do is we have to go back to the client. And you notice that's kind of how we've been operating, right? We work on one side, we figure out what we want to send, and then we go to the other side and we figure out how are we going to receive this. So we have to receive the game state and the time and then update our client side based on that incoming information. So if we head to the client script and we look at our game objects update method, so it's right here, the game objects update method, you can recall that the update method is called every iteration of our main game loop. And you can see here that we are always sending our player information over to the server, each iteration of that game loop. So as we move our player, we're sending that information over to the server. And what the server is now doing is it is gathering all connected players, information and putting it into our game state, and it's trying to send it back to us. So we definitely want to make sure that every iteration of this game loop, we are also receiving that information. So, in our code right here, or in our comment where we just say send the player's current info to the server, I'm actually going to change that. And I'm going to say, and receive an updated game state. So we want to make sure that we're also receiving something every iteration of our game loop. And so we'll call self dot, if we scroll down just a little bit, or actually I think we got to scroll up, we've got receive game state, receive all information about all players from the server during the game. So we definitely want to call this method and then write this method. So we'll say self dot receive, R-E-C-I-E-V-E, game state. It's easier for me to spell correctly if I actually say it out like that. So I think this looks perfect here. Okay, so let's go write this method right now. So I'm just going to scroll back up. Here we are in receive game state. So what do we need to receive? Well, recall, what are we sending over? We're sending over the game state, and then we're sending over the server time. So we got to grab both of those things in this method. So we'll say receive the game state. So we'll get the packet size of the incoming message. Self. Now we got to get to our, let's just remember, we got to get to our socket, which is stored in our connection object here inside of the game. So self.connection dot player socket. Yep, dot player socket dot receive. How big is the header? Well, it's self.connection.header length. And then that's a bytes object, so we're going to decode, and we're going to put in self.connection.encoder, and that's where we're storing our UTF encoder. Okay, and so now let's use the packet size to get the game state. So we'll say game state JSON. It's going to be a JSON file when we get it. Is self.connection.player_socket .receive. How big is this packet? Well, we got that information from our packet size. So the header told us. So we'll say we want the int value of packet size, and we've done this before, which is why I'm moving a little quick here. We don't have to decode it. JSON will do it. So we'll say, hey, game state is equal to JSON.loads, and we'll pass in game state JSON. So remember, this is an encoded string. We pass it in, it's no longer encoded, and this is a list now. So that's going to be a list. And so now we have a new game state. If you recall, our game object on the client side, if I scroll up to where we initialize it, it has a game state attribute, which we initialized as a blank list. So let's update the game object's game state attribute here on the client end. So, right, we've got a new game state, so let's update our, we'll say update the client's game state. So we'll say self.gameState is equal to game state. All right, that worked pretty good. So that's going to get us our game state. Now let's get the server time. So we'll say receive the server time. So again, we'll do a packet size. So packet size is equal to self.connection.player socket.receive, self.connection.header length, and then we'll decode it, .decode self.connection.encoder. Now that we have that, we can receive the round time, and we will set the clocks. I think we have a round time attribute, don't we, in the game object? Let's just scroll up and make sure we have a round time attribute. Yep, variables to hold the state of the current gameplay locally. We have a round time attribute, and so it starts at the maximum value, and then we're decrementing it over on the server. So let's update that value. So we'll scroll down. Where were we? Receive the server time right here. So we'll say self.roundTime is equal to self.connection.player.socket.receive, and in here is going to be the integer value of our packet size. And if we think, we should probably decode it, right? We got to decode this because this is going to be a string, and so we'll decode it. .decode, and we'll pass self.connection.encoder here. All right, perfect. And I think, yeah, I think this works out pretty good here. I think this works out pretty good. We could cast it to an integer. We could cast round time to an integer right here, but maybe we'll do it. We'll do it later. We'll do it later, I think. Okay, so this looks great here. So now our client has access to the updated game state and the updated time, and our game state is going to include things like every player's score, everyone's current position, so let's process the game state to see what updates it might have on our current game loop. And so over here on the client side, we have a process game state method. So we'll say process the game state information. So we'll call self.process game state. Okay, so let's go right process game state. All right, in process game state, we're gonna do a few things. First, I'll say we're gonna do them all based on the data that was passed over from the server, right? So first, we'll update our player, the player that is connected to this client's coordinates. So we'll say update the players. We'll say update this player's coordinates in response to a collision. So if you remember, on the server end, we said that where we are in process game state, if our player collided with any other player, we gave them a point, and then we changed their coordinates. We positioned them back at their home base, at their starting location. So what we want to do is make sure... Oh, where'd my IDE go? Here we go. What we want to do is we want to make sure that if that collision occurred, we update the coordinates here on the client side. So we're going to say for player in self.gameState. So if you recall, game state, we've attached it right here to our game, is a list, so we can loop through that list. We have a player in each list. What we have to do, though, that player is currently a string, so we're going to say player is equal to json.loads player. So we'll turn it back into a dictionary, and so now I'll say player is now a dictionary. We're going to check first to see if player, if their number is equal to our own player's number, so self.player.number. So is the player in the iteration of this loop, is their number equal to the player that this client is running? So if they are equal, then we will update their coordinate. So we'll say, okay, self.player.cord. Our coordinate is going to equal the player dictionary, and we'll access the cord key. And then let's also update our x and y values. So we'll say self.player.x is equal to, we can do self.player.cord. We can do the first element in the coordinate, and then we'll do self.player.y is equal to self.player.cord. We can do the second element in that coordinate. You probably could have also just grabbed them from the player in the dictionary. You could have done player X and player Y, but this works out too. Okay, perfect. So that's going to update our coordinates. So that should make sure that when a player collides, they are effectively moved back to their home base. So they're moving around the screen, they collide, they get a point, and then they go back to their home base. You can think about it as maybe like they deposit the point by going back to their home base. So now what we'll do... let's see, what do we want to do next? Well, while we're looping through each player, let's also get whose score is currently the highest. So if you remember, we're not keeping track of a client score locally on the machine, although that information is over on the server. But let's try to figure out like who's currently winning the game here for us. So what we'll do is I'm going to start at the top outside of the for loop. I'm just going to create a list. I'll call it current scores. And it'll be a blank list. And now in here, what we'll say, we're looping through our players, we're turning the players back into dictionaries. What we'll say is determine who is currently winning. Now, if you remember, I'm going to just scroll up to our game's initialization method. I think we have some, here's our game's initialization method. We've got some variables that are going to help us here. We've got high score is equal to 0 and winning player is 0. So that's going to help us out a lot. I think we're going to update these values, our high score and winning player attributes, now. So here we are back in process game state. So we're looping through our player dictionary. So player, our game state list to get our player dictionary. So player is a dictionary, and we're going to say if this player is score is greater than self.high score. So if it's greater than high score, then what do we want to do? Well, we're going to change our winning player. We're going to say self.winning underscore player is no longer 0. It will be assigned to the player that we're looping through, its number, so player number. And we will set our high score. So we'll say self.high score, ooh, don't capitalize that S, self.high score is equal to this player's high, well, it's not high score, it's just score. All right, so that'll loop through and update who is currently winning and what the current high score is. But we also could have a condition where we have a tie, and so we want to make sure we do some stuff for that. So we'll say inside of our for loop, as we're looping through each individual player, we're going to add the score to our current score list to process for a tie, we'll just say. So I'm going to say current scores dot append player score. So this is just a local variable that will exist inside of our function, but it's going to help us. Once this for loop is done and we've run this for loop for each and every player, we'll know who the winning player is, what the high score is, unless there's a tie. Because if there's a tie, we're just going to give it to the first person that it happens to be in the for loop, which is why we're creating a list of all of our current scores here as we're looping through them. So now that we have that list, we can check for a tie outside of the for loop. And so how are we going to do this? Well, I'm going to just create a counter variable. I'll call it count is equal to 0, and we'll say for score in current scores. So I'll loop through my list of current scores, which we've appended to right here. What I'll do is I'll see, is the score that we're looping through equal to self.highscore? Is it equal to the high score? If it is, I'm going to increment count by 1. And you know what? I don't like the name count. We'll say count's fine. So as long as that variable is equal to 1, we're good. That means there's a clear-cut winner. But what we'll say outside of the for loop, if count is greater than 1, if it is 2, if it is 3, if it is 4, then that means there is a tie. So I'll actually put a comment here. I'll say there is a tie for first place. That means no one is winning. So if no one's winning, what should we self.winning player to? Well, we'll set it to 0. 0 will be the place, the value that we use for a tie. Okay, and so that looks great. All right, so now what we can do is let's head to our update method. Actually, no, I think our update method is pretty good. Let's head to our draw method. Our draw method is what we want to do now because we've got a lot more information that we want to draw, I think, to the screen. We've got scores, we've got times, all that good stuff. The first thing that we'll change here is we're going to give some visual feedback for who is winning the game. So the first thing that I'll do at the top of my draw method of my game, I will say we're going to fill the display to the secondary color of the current winning player. So if the red player is in first place, the screen on everybody's game client will be red. If blue is winning, then it'll be blue. If nobody's winning, if it's a tie, then it'll just be its regular old black color. So what we'll do is we will loop through our game state just like we did before. Remember, the game state is attached to our game object. So we'll say for player in self.game_state. We'll get the player. The player is currently a string, so we'll turn it back into a dictionary using json.loads player. And then we'll check if the player number, if that player's number is equal to our current winning number, self.winning player. And if it is, then let's fill in the surface, our display surface, which is the name of our game window, display surface dot fill the player's secondary color, so S color. Now, you might say, you got a for loop right here and you're looping through, why not just do it right in here? Well, with drawing and blitting to the screen, the game window, it's I guess you could say it's like sequential. So like we want to draw the background in first and then draw the things that go on top of it next. If we drew these things first and then drew a background, that background would go over everything else and you wouldn't be able to see it. So we got to do this first. All right, perfect. So now, and also I'll just say here, what if the player's winning number, what if winning number is 0, then none of these are going to match? Don't worry, because what are we doing first? Down here in our main game loop, we are filling, as a default, we're filling the surface black. So that is okay. That is okay. All right, so that will draw the background in the way that we want. So now let's work on displaying the score. So kind of like before, I'm going to create a list. I'll say create a list to hold all scores. So we'll say current scores, it will be a blank list, and it'll be a local variable. And I'm doing this because I've got another for loop here, which is running, which is kind of nice. But I don't want to write the scores in here because I could write the scores and then write a player on top of it, and you wouldn't be able to see the scores. I want the scores to be on top of everything else, so I'm going to draw them. I'll draw them last. However, inside of this for loop, there's no reason why I can't get access to all of these players' current scores. So let's do that. So we loop through our game state for each player, we turn them into a dictionary, and then right here I'm going to say prepare the score to be drawn later. All right, so I'm going to first just create a score variable, and I'll put some text in here. It'll be a P for player plus I want a string representation of the player's number, so the current player's number. So it'll be like P1, P2, P3, and then I'll put a colon with a space, and then I will add to it the string representation of this player's score. So it'll be like, P1 colon 5 if their score is 5. So that's the message that we're going to use. So now let's create a score text object. So score text, let's render it to the screen. So we'll call the font object that we had created way back in like video 1, font dot render, and then we'll put the message that we want to render. It's our score message. Anti-aliasing is always true for us, and the color I want is white. Now I'll get a rect for this score text. So I'll say score rect is equal to score text.get rect. And now what I'll do is I will position the score rect based off of the player number. So like if my game window, player 1, I'll have the score be where they started, player 2, I'll have the score be where they started, or similar, close to it. Player 3 where they started, and player 4 sort of where they started as well. So we'll come over here and we'll say if player number is equal to 1, then we're going to we want to position this in the top left corner. So I'm going to use the score rex top left attribute to do this. So I'll say score rect, move my cursor, score rect dot top left is equal to, remember, the recs need a coordinate where it's the starting x value, the starting y value, and oh, no, to position, I'm sorry. To position, we just need x and y values. So our x value, I'm going to use the player's starting x value, and then for the y value, I will use the player's starting y value. So the particular player in this iteration of the game loop, if its player number is 1, we're going to find their starting x and starting y, which is right up here in the left-hand corner, and we'll put the score right there using the top left attribute. I'm actually going to copy this because we're going to see that we do that quite a bit. Elif player number is equal to 2. We're going to do the same thing, except now top left is, we're going to be over here in this corner. Top left is going to push us off. We're on the right side, so I'm going to use the top right attribute to position. So we'll change that to top right. All right, let's paste another. Oh, we'll do elif player number is equal to 3. Our third player is in the bottom left corner. So top left is going to be bad because it'll push our text below the screen. So we'll do bottom left as the attribute of the rect that we're positioning. And then I'll just do an else block here to catch the fourth player. I think that should be fine. The fourth player is in the bottom right corner of the screen over here. So we'll say, we'll use the bottom right attribute to position the rect. Awesome. Lastly, what we'll do right now is we've got this list of current scores. We said we're not going to draw the score right now. We're going to draw them later, so we ensure that they are the last thing that is drawn. But I should append the current score to our list. So I'll say current scores dot append, and and we'll append it as a tuple. We'll do the score text, so score text, and we'll do the score rect, because we know that when we blit, if we just scroll down, right, when we blit the text to the screen, we need the time text and the time rect. All right, so we'll do that right there. Awesome. So this looks pretty good. And then if we continue on in this for loop, we're drawing the given player. Once we've drawn the given player, we're drawing our particular player with an outline. And so then this is the last moving thing that we're drawing. Like, I don't really care about the time and the player. Those are static. They're not moving. So once I've drawn our player, now I will draw all scores last, so they are always on top, we'll say. So we'll loop through our list of current scores. We'll say for score in current scores. We'll blit them to our display surface. So display surface dot blit. What do we want to blit? Well, if you look, we appended it as a tuple. The text is the first element, so we'll do score at index 0, and then the rect is the next element, so score at index 1. All right, so I think we're pretty good here. Oh, you know what? One last thing. Since we're in the draw method right here, I think what I'm going to do is we're drawing an outline, a magenta outline around our player object. But you know, the server is going to change the size of the player. Whoever's running the server can make them really small, so it's hard to collide, or make them really big, so it's easier to collide and it's more chaotic. I want the size of the outline here that we're drawing to sort of vary with the player size. So instead of hard coding it as 2, what I'll do is I'll do self.player.size. All right, so we're getting our player object size, and I'm going to divide it by 10. So if the player size is 20, we're going to outline it by 10. If the player size is 40, we'll outline it by 4, and it'll grow with the player. This, I believe, is going to give us a float because we're doing division, so I'm just going to cast it to an integer so that we have the thickness set the way that we need it. All right, I think this is perfect. Let's actually test this now, and if this works, I'm going to be super, super happy. So we're going to run our server, and hopefully now if we run our game with our clients are going to send their updated gameplay state to the server. The server is going to compile it for all players, and then they're going to send an updated game state back to each client, and we're going to use that updated gameplay or game state to kind of like draw these changes to our respective boards. So I'll hit enter to start. Oh, and we've got an error. Of course we do. So let's debug this in real time. Where is it? Okay, so it looks like it is in my server file on line 252. I've got a spelling mistake. So line 252 on my server. 252. Look at that. So I said player info JSON is player socket.rect. It's not .rect. We want to receive RECV. All right, RECV. So I got to make sure you change that. Hopefully you didn't make that mistake, and maybe you laughed at me when I made it. Like, what's this guy doing? He doesn't know what he's talking about. So now we'll change that. The server's running. Okay, let's check our clients. Hopefully this works. Second try is the charm. That's going to be our phrase. We're going to be optimistic here. So here's this player. Here's this player. I press enter to play. Enter to play. Oh no! And look at that. We got another error. So let's just see. We'll debug it in real time. String object has no attribute encoder. Oh yeah. So if we go to line 307 now in our server file, 307 in our server file, right here. Player socket.send. I have header.encoder. That's not right. It's encode. We call the encode method. So that was in my send game state method of the game class. So right here I had to change encoder to encode. All right, so I really wanted it to be second try is the charm, but I'm very confident now that third time is the charm. Third time is the charm. So I'm going to run this. We'll set this up. Again, live debugging, it's good to see it in real time. These are pretty easy errors though to fix. I mean, these are just kind of oversights on my part. So we're going to move this here. I'm going to move this over here. We'll press enter. We'll press enter. All right, we got play. And as I move the green square, you can see the green box moves. Oh, and look at that. I collided. I earned a point, and I went back to my home position. And so now I'm going to control the red box. All right, red box works. I'm going to collide with my red. I'm going to collide with the green square. So red's going to collide with green, earn a point, and it should be a tie. If it's a tie, then the screen should go back to black. And it does, because now there's no winner. Hey, look at that. That's cool. So let's go. Let's let red win and see how that works. Hey, and that's pretty good too. All right, so we can continue to kind of play. Green can take the lead. Red can come back and tie it. And then let's have green come back and move around whoosh, and get it right at the end. We're going to score some points for green. They collide. They come back to their home base. And so now... Okay, that's kind of funny. If you notice, ideally, everything's working pretty great. Every feature that we've coded is operational. The client is moving their player. Then they update the coordinates. We send them to the server. The server is processing and compiling a game state and then sending all important information back to each individual player. The client then updates on their end, and we've got some fun gameplay here. But we can see there's still some work we have to do in terms of the reset of the game. Like when round time hits 0, we shouldn't be able to move anymore, and the game should sort of stop, and we should trigger whether or not we want to reset. So I think that might be the last thing that we have to put into place here on our game, Color Collide. So we'll begin that in our next video. I'll see you then.